Yet another question about quantum numbers. What we need to do in this problem is first determine if the set of quantum numbers is valid, then ask to what level do they specify, and then how many electrons could have that designation. In many ways, the number of quantum numbers you have is like the specificity of an address. So let's say, for example, you're at Ignatius and you're in room 364. Knowing first that you're in Chicago would be like the most general part of the address. Knowing that you're on Roosevelt Road would be the next most specific level. Knowing that you're at 1076 West Roosevelt Road, that's another level of specificity. And then knowing that you're in room 364 tells you exactly which room you're in. Well, an electron is a lot like that. The principal quantum number is the most general specification, followed by angular number, followed by magnetic number, and then if you could get a valid spin number, there's only one electron that could have all four quantum numbers that apply to it. So that would be the most specific level. So let's start with the first one, and knowing what we know already about quantum numbers. If n equals 2, can the angular momentum number be 1? Yes, it can, because angular number can be up to 1 less than the principal number's value. So I'm going to say OK for that one. Can the magnetic number be -1 if the angular number is 1? Absolutely. The magnetic number can range in value from negative angular number to positive angular number. So that's okay. And then spin numbers, maybe we haven't talked much about this, but your spin number, if it's valid, can only have one of two designations, either positive 1/2 or negative 1/2, indicating which direction the electron is spinning within a given orbital. Well, negative 1/2 is a valid designation. So if all four quantum numbers are valid, then that can only apply to one specific electron. Here they're asking for electrons. One electron can have all four numbers. Part B. If your principal number is 1, can your angular number be 0? Yes. The angular number can range up in value to 1 less than the principal number. Well, 0 is 1 less than 1, so that's okay. Can the magnetic number be 1? Yes, that's fine too. That tells us which specific orbital we're talking about. It's the lone orbital in the 1s sublevel. Well, this question is asking how many electrons can have, in this case, the 3 quantum numbers that they're giving us. Well, since up to 2 electrons can fit into any given valid orbital, I'm going to put down 2, because 2 electrons can have those 3 quantum numbers. It's kind of like how many students can be at 1076 West Roosevelt Road? A lot of them. More than one for sure. We're talking about more than one classroom. Part C, n equals 3. That's all they tell us. Well, how many electrons can fit in the third principal energy level? Well, maybe it's helpful to list out the sublevels, 3s, 3p, and 3d, no more than that. How many orbitals can you have in each of those? Well, in any s sublevel you can have 1, in any p sublevel you can have 3, in any d sublevel you can have 5. Altogether that's 9 orbitals times 2 means you can have up to 18 electrons with n equals 3. Part D. Can n ever equal 0? No. The principal quantum number doesn't have an upper limit, but it does have to be a counting number. So it can be no less than 1, and you could only go up by whole numbers from there. You cannot have a principal number equal to 0. So this may seem like a trick question, but 0 electrons can have that set of quantum numbers because it's not a valid set. Last problem. If n equals 3, can L equal 2? Yes. L is 1 less than the principal number, so that is an okay number. If L equals 2, can ML equal negative 1? Yes, that's within the range of negative angular number to positive angular number. So that one is also okay. And then lastly, if your spin number is positive 1/2, is that valid? Sure. That's one of the valid spin designations that you can have. So in the last case, we have all 4 quantum numbers valid. That tells us which specific electron. Only one single electron can have all 4 quantum numbers valid.